In today's lesson, we're going to continue multiplying polynomials. Remember, when you multiply polynomials, all we're doing is applying the distributive property to the expression. Today, however, we're going to focus in on the patterns that are produced when you multiply polynomials together. In order to be able to do this, we need to review how we classify polynomials together. We classify polynomials in two main ways. First, by their degree. You may recall that the degree of a polynomial is the degree of the variable that's displayed in the monomial itself. Since this monomial has a degree of 2, we would say that it is a second degree polynomial or a quadratic. Our next example, 6, doesn't contain a variable, which means its value remains constant. Now if it does have a variable, it would be x or y or z or some variable, but it would be raised to the 0 power. So we would say that this term is a 0 degree, or otherwise known as a constant, because its value doesn't change. It remains at 6 the entire time we use the 6 in our problem. Our next expression has two terms, 6x minus 5, and the degree of the first term is a 1. Now, first degree polynomials are referred to as linear models or linear expressions. Our last example has three terms, and the greatest degree is 4. So this polynomial has a degree of 4. We would say it's a fourth degree polynomial that has three terms. Which brings me to my next way of classifying polynomials, and that is by the number of terms. Remember, terms are parts that are being added in a problem. In our first example, we only have one term. And if we only have one term, we know that's considered to be a monomial. Our next example was just a 6. Once again, it has one term, so it's considered to be a monomial. The third example has two terms. Now if an expression has two terms, we call that a binomial. Bi meaning two terms, 6x and negative 5. Our last example had three terms, so we call that or classify it as a trinomial. It has three terms, tricycle, 3 wheels, trinomial, 3 terms. An easy way to remember classification. Throughout the lesson today, you're going to hear us referring to the products either by their degree or by the number of terms. Now let's multiply 8t minus 11 times 6t plus 1. To do this, we're going to be using the distributive property, and we're going to format our work in one of these three methods. I'm going to choose the vertical format today. So I'm going to rewrite the expression into a vertical format. 8t minus 11 times 6t plus 1. Now I'm going to apply the distributive property. I'm going to distribute the first term. So 1 times negative 11 gives me negative 11. 1 times 8t gives me a positive 8t. I'm going to distribute the second term. 6t times negative 11 is a negative 66t. 6t times 8 is a positive 48t squared. The final step will be to combine like terms. 48t squared comes straight down, minus 58t, adding the coefficients only, minus 11. So the procedure to multiplying polynomials is simply to distribute, in some cases twice, in some cases 3 times, and then to combine like terms to find the result. In this case, we have a quadratic trinomial. The degree is 2, and it has 3 terms. A quadratic trinomial. Now let's begin by focusing in on the patterns of the products that are produced when we multiply polynomials together. Let's start off with x plus 6 times 2x minus 7. I'm going to begin by distributing the x across the 2x minus 7 using FOIL. X times x is 2x squared. X times negative 7 is negative 7x. 6 times 2x yields a positive 12x. And 6 times negative 7 yields opposite 42. Final step will be to combine like terms. 2x squared, 12 minus 7 is a positive 5. The constant of negative 42 comes down. So this expression, x plus 6 times 2x minus 7, yielded a quadratic trinomial, 2x squared plus 5x minus 42. Our next example is two linear binomials multiplied together. And once again, let's distribute. 3x times 3x yields 9x squared. 3x times positive 5 yields a positive 15x. Distributing the second term across yields a negative 15x. Negative 5 times a positive 5 yields a negative 25. Final step will be to combine like terms. 9x squared minus 25. So this expression, 3x minus 5 times 3x plus 5, yielded a quadratic binomial, 9x squared minus 25. Let's look at our third example today. 5y plus 4 times 5y minus 4. Once again, let's use the distributive property to multiply. 5y times 5y yields 25y squared. 5y times negative 4 yields a negative 20y. Distributing the 4 across yields 20y. Last terms yields negative 16. Final step will be to combine like terms. 25y squared. 20 minus 20 is 0, so I bring down the constant of minus 16. And once again, these two linear binomials produced a quadratic binomial. The greatest degree was 2, and it only had 2 terms. Let's look at that final example today. X minus 4 times x plus 6. Once again, we distribute. X times x is x to the second. X times a positive 6 yields 6x. Going to distribute the negative 4 across. That yields negative 4x. Negative 4 times a positive 6 yields a minus 24. Once again, the final step is to combine like terms. 6 minus 4 is 2, minus 24. So this expression produced a quadratic trinomial. Now remember, our focus today is on the product patterns, the patterns that are produced when we multiply. So take a look at the products. These two products were quadratic binomials. How are the original expressions the same? The product in the top left corner and the bottom right corner were quadratic trinomials. How are these original expressions different from the expressions that produced quadratic binomials? Is there a way to predict how many terms the product will have? For example, this expression has 3 terms, but this one only has 2. Is there a way that you can determine before you multiply how many terms the product will have? Write your observations down in your notes and be prepared to talk about them in class tomorrow. Let's take a look at one more pattern. In our first example, we're going to multiply two linear binomials together. 2a minus 3 times 2a minus 3. Once again, we're going to distribute. 2a times 2a yields 4a squared. 2a times opposite 3 yields an opposite 6a. Distributing the negative 3 across yields another negative 6a. And negative 3 times negative 3 yields a positive 9. Final step will be to combine like terms, which yields 4a squared minus 12a plus 9. So these two linear binomials produced a quadratic trinomial. Let's take a look at another example. This is one we haven't seen before. 7a plus 2 squared. Well, the base is 7a plus 2, and we know we need to use it twice, so the first step will be to expand the problem. 7a plus 2 used twice. And once we expand it, I think we can see how to evaluate this expression quickly. 7a plus 2 times 7a plus 2. So we see that we just simply need to distribute. So 7a times 7a yields 49a squared. 7a times 2 is a positive 14a. 2 times 7a is a positive 14a. And finally, 2 times 2 yields a positive 4. The next step will be to combine like terms. 49a squared, 14 and 14 make 28, and the constant is a positive 4. So once again, two linear binomials produced a quadratic trinomial. Now remember, our focus is on the patterns that are produced when you multiply polynomials together. So we're focusing in on the result. In this case, these two quadratic trinomials. Let's look at another example. We're going to need to expand this before we can multiply it. So the base, once again, is 5x minus 3. I need to use it twice. So let's begin by distributing. 5x times 5x yields 25x squared. 5x times negative 3 yields negative 15x. Negative 3 times 5 yields a negative 15x. And negative 3 times 3 yields a positive 9. Final step will be to combine like terms. 25x squared comes down. Add the two middle terms, negative 30x. The constant on the end is a positive 9. Once again, we've got a quadratic trinomial that was produced by these two linear binomials. We're trying to focus in on similarities between the products that have been produced today. One final example. 2y plus 3 times 2y plus 3. So the base is 2y plus 3. We need to use it twice. We start by distributing. 2y times 2y is 4y squared. 2y times positive 3 gives a positive 6y. We'll distribute the second term across. That begins with a 6y and then a positive 9. Our final step will be to combine the like terms. That yields 4y squared plus 12y plus 9. And once again, a quadratic trinomial that was produced by two linear binomials. Now remember, the focus of today's lesson is on the product patterns. Okay? So take a look at these products. Each of them is a quadratic trinomial, and they have certain similarities. List all the similarities that you can observe. Look at the expression that yields the quadratic trinomial. What are the similarities there? How are all of these expressions the same, or are they different? Write your observations down and bring them to class.